All right, let's just jump right into it. We're going to tackle a question that, honestly, it might just shake up how you see everything around you.
I mean, think about it for a second. Look around you. You see a world of objects, right? The chair you're in, the screen you're looking at, the stars up in the sky, they all seem separate. But what if that's just, well, an illusion? What if our perception is playing a little trick on us? Some really brilliant thinkers, both from way back when and today, think that might be exactly what's happening.
So you've got these two totally different ways of looking at reality. On one side, there's our everyday common sense view. The world is full of distinct, solid things that stick around. A rock is a rock, right? But then you have this ancient perspective. The Greek philosopher Heraclitus said everything is in flux, like a river that's always changing. And Buddhist philosophy talked about momentariness, the idea that everything is just popping into and out of existence, instant by instant, a constant, seamless flow.
So this leaves us with a huge mystery. I mean, if reality isn't a collection of separate things, then what is it? What's the actual fundamental ground of being?
And here's where it gets really fascinating. Modern science, of all things, has been on a strikingly similar path. Physics has been slowly dissolving this idea of a world made of solid objects and pointing towards something, well, something a whole lot weirder.
The first really big clue came from Einstein. His theory of general relativity completely changed the game. It showed us that space and time aren't just this empty background for things to happen in. Nope, they're actually woven together into this single, smooth, continuous fabric called space-time. One unbroken whole.
But the plot really thickens when you get to quantum mechanics. It tells us that at the most fundamental level, reality is this continuous wave of pure potential, what physicists call the wavefunction. It's just a smooth sea of possibilities. But, and here's the puzzle, the second we try to look at it, to measure it, that smooth wave seems to just snap into a single definite particle. It's so strange that it leads to this incredible idea. Maybe even space-time itself isn't the bottom floor. Maybe it actually emerges from something even deeper.
So, what could possibly be deeper than space and time? Well, physicists now have a prime suspect for what this ultimate continuum, the thing from which everything else arises, might actually be.
And that prime suspect is called the universal wave function. Now get this. The idea, championed by physicists like Sean Carroll, is that there isn't a separate little wave for every single particle. No, there is just one single, massive, continuous wave function for the entire universe that describes everything, every particle, every field, all of it, evolving together as one unbroken whole.
This leads to the mind-bending many worlds idea. It says the wave function never actually collapses. Instead, every time a measurement is made, the universe branches. Every single possible outcome actually happens, just each in its own brand new reality. So the randomness we think we see, that's just our own limited view from inside one of the countless branches.
Okay, so if this is true, the implications are absolutely staggering. It means there is only one fundamental object in all of existence, the universal wave function. Everything else, particles, people, even those parallel worlds, they're not separate things. They're just features of this one single reality. And get this, even space-time itself isn't fundamental. It emerges from patterns of quantum entanglement, that spooky connection between particles. It's almost like space is a hologram projected from the connections within that one great wave function.
Okay, so armed with this powerful idea of a primary continuum, we can now look at the biggest origin story of them all, the Big Bang, in a completely different way.
You know, the old picture of the Big Bang was pretty simple. It was a beginning from absolute nothing, an edge of time. But if you look at these more modern models, you see a totally different story taking shape. Whether it's a smooth start with no boundary or a bounce from a previous universe, the theme is the same. Our universe probably emerged from something that was already there. In Sean Carroll's view, the eternal wave function just hit a point of very low entropy, a state of perfect order, and our universe branched off. The key idea here is that the Big Bang wasn't a creation out of a void, but a transition within a pre-existing reality.
So, let's tie this all together. What kind of stunning, final picture of reality does this all paint for us?
So instead of building the world from the bottom up with tiny little Lego bricks, this view says reality crystallizes from the top down. You start with the one unbroken whole, the continuum. Then, for just a moment, a boundary forms within it, and a little package of reality appears. This package could be anything, a particle, a star, maybe even a single thought. And then, just as quickly, the boundary dissolves, and the package melts back into the whole. It's like a ripple appearing for a second on the surface of an ocean and then disappearing back into it.
And that's really the ultimate takeaway here. Existence isn't static. It's not a collection of fixed objects sitting there.
It's a dynamic, rhythmic process. It's a dance of appearing and disappearing, of becoming and dissolving, all happening within one single eternal continuum.
And that leaves us with one last thing to really chew on. If the entire cosmos is just this rhythm, these momentary packages crystallizing out of an undivided whole, then what does that make your own thoughts, your feelings, your very sense of self? Are they too just fleeting ripples, momentarily appearing within some much deeper, universal continuum of consciousness?